Hello, and welcome to Rangle.io's From jQuery Soup to Reusable React Components. My name is Michael Bennett, and I'm going to be walking us through a whole bunch of different conversation pieces about jQuery and React, where the web has been and where it's going and where it is now. So, just getting started, the overview is basically the dawn of the web. We'll talk about the first sort of great browser war that erupted, the rise of jQuery, the second great browser war, single-page applications, the dawn of React, the component model, and then state. So all of these things are different aspects of where we've been and where we're going in terms of web applications and what the web can actually do for us. And just a quick note on the title about jQuery soup. It's a bit of a pejorative, and we're actually not going to besmirch jQuery too much during this. We'll actually take a look at some of its nicer sides, and then we'll actually look at why libraries like React have come about and the problems that they solved versus the problems that jQuery solved. So the dawn of the web. The web, of course, is internet-based infrastructure. So it's a set of protocols that operate on top of the internet protocol stack. It was developed by a gentleman named Tim Berners-Lee in the late 1980s. So they hadn't, as much as a lot of the technology we use today is all derived from stuff that was invented in the 50s, 60s, and 70s, they still hadn't really envisioned how much people would end up coming to use this. So it's pretty amazing how much the early architects of the web actually got right. The web started as a simple means of sharing linked documents. Rough analogs at the time were like not OS X. It wasn't even OS X at the time. It was Apple's HyperCard system, and there were other ways of loosely stringing together application-like things or just rich documents. And the web, the first problem it attempted to solve was rich documents. And so a lot of the history and the problems that we end up trying to solve actually come about from the web's organic roots in these sort of rich documents. And in the very early days, there weren't scripting, there was not scripting, I should say. There were not images. Eventually, in the early 90s, we got some more sophisticated scripting, and then we ended up getting things like plugins for browsers. But even by the 90s, when the web was starting to become pretty mainstream, to the point where even in a 90s sitcom you'd hear the term email crop up, web applications weren't taken super seriously by quote-unquote real programmers. I mean, real programmers, in that sense, were sort of worried about writing the underlying protocols or doing implementations in compiled languages, and the web was not even something for consumers. It was just an information exchanging paradigm. It's not to say that real programmers weren't working on it. It's just this sort of notion of, quote, real programmers, and I emphasize the quotes, is that they wouldn't deal with it. And it's not to say that there weren't and there aren't quality web programmers on it. There's just this sort of attitude that is slowly eroding, but it's still there, and you can still see it in comment boards. This sort of attitude that web programming is somehow not real, even though it still involves all of the same manipulation of computers that traditional programming languages like C do. So in the early days of the web, this actual flow of information has not changed too much. And we are about to actually see it change with HTTP2 a little bit, but the general gist of the way the internet works is that you have a client, they'll enter something like example.com. In the background, there'll be a DNS request that figures out the IP address for example.com. It'll hit a server, and the server will return a web page. Typically in the early web, or actually always in the early web, these requests almost always introduced a new web page or a new file download that was going to happen. And as we look through the progression of the web, we'll see how this paradigm has changed a little bit. Although fundamentally it's still a client-server interaction, it's just the concept of getting a new page every time has changed. So after the sort of during the early 90s, actually, there was the first great browser war. This isn't really a formal term. It's just something that ended up coming about. It was very much shown as Netscape versus Microsoft. And, well, Microsoft, of course, had a whole bunch of other ventures besides web browsers. And Netscape, on the other hand, was somewhat organized around the idea that they were going to topple Microsoft. I mean, they made a lot of bold claims. Both companies ended up producing a lot of interesting innovations at the time that really helped push that early web forward. And Microsoft eventually won the browser wars, and Netscape sort of disappeared and was reborn into Mozilla, so to speak. one of the products of this was Internet Explorer 6. As the browser wars sort of wound down, it became the dominant browser. And as much as we tend to pick on Internet Explorer 6 today a lot, or maybe yesterday, I think it's been phased out now to the point where we don't have to think about it anymore, there was a time when it was actually pretty cutting edge. As much as open source advocates might not have liked it, it was there and it was doing its thing. And one of the great byproducts of the first great browser war was that XHR, or XML HTTP requests to be verbose, they came about, and they're a mechanism that allow web pages to request data from the server without getting a whole new page. And it doesn't really seem like very much, but this XHR system, or XHR-like requests, which happen in the background, are the backbone of single-page applications that we've come to embrace today. So as the browser war sort of wound down, stagnation ensued. Internet Explorer 6 became dominant. A lot of client-side programming was done with Microsoft-specific controls. Flash and Java applets gained a little bit of ground. And overall, I mean, these quote-unquote real programmers who worked in their C and C++ lands were still not overly impressed with browsers. And there's a lot of good reason for that. I mean, JavaScript at this point was still quite slow. So there's a bunch of conditions around this time, early 2000s, that led to the creation of the jQuery library. So at that time, JavaScript was interpreted and slow, and it was largely used for CSS, what CSS does today in a lot of ways. Despite the competition of the browser wars, the DOM API in the early 2000s was severely fragmented. It was really hard to write cross-platform JavaScript. I think during that time, Microsoft-specific implementation, JScript, was being sort of phased out. Sites, of course, at this time were very much page-based. And when I say page-based, I mean they were, web pages. These were still very much documents. They just had a little bit more interactivity to them. And as the early 2000s progressed, we started to see a lot more interactivity coming. And a lot of this was happening with server-side logic. I mean, back in the 90s, there was limited server-side logic. It was still happening through like Perl scripts and CGI and things like that. But it was really in the early 2000s when XHR started taking foothold that server-side logic started to do a little bit more than just generate new pages. Nevertheless, a lot of server-side frameworks were oriented around producing templated JavaScript and generating those kind of things server-side. So jQuery, what it allowed us to do, and what it actually did, was it provided a really great API for the DOM. I mean, it's easy enough to knock jQuery today, looking back in hindsight, but at the time, with very slow JavaScript access, most of the stuff people were doing was basic DOM manipulations, trying to even out some things that CSS has now solved. And so some of the stuff that jQuery gives you to actually solve these problems are like, it makes DOM traversal fun. Working with the native DOM API back in those days was not so fun, especially because the differences between browsers were quite glaring. Manipulating the DOM with jQuery is very easy. I mean, you can insert DOM nodes, you can delete DOM nodes, update them, hide them, show them, apply CSS, take it away. There's just a ton of different features jQuery offers to do that and define these DOM nodes really easily. And in 2006, this was a really, really good thing. jQuery also provides a really simple HTTP interface. So what that really means is it's a wrapper around your sort of XHR type stuff. And the way jQuery does it is in a pretty natural progression where you can just make an AJAX call and then and then actually specify what your event handler is going to be, and jQuery behind the scenes would normalize out the difference between early Microsoft browsers or early Netscape browsers. And I mean, this is going back to a time when Chrome still didn't even exist. So a lot of these features were really, really, really useful at the time. And jQuery wasn't alone. There were other rival libraries. It's just that the API jQuery produced to navigate the DOM is just a lot of fun to use. And it really took off. It became to the point where people actually associate JavaScript programming erroneously, but they still do it. They associate JavaScript programming with jQuery a lot, especially if they don't have programming backgrounds. So just an example of what jQuery would actually let you do. in a traditional DOM, we might have something like a body element, which is at the top of this, or not a body, but a div element with an ID on it. And if we wanted to get this through the browser, in most browsers today, and actually in all browsers today, we call document.getElementById and reference the my container and store a reference to that DOM node and work with it later. What jQuery let you do is it took that very verbose API that was a lot rougher back in those days too, and it made it so outside of this $ and this hashtag and the brackets, you're more or less actually just calling the selector of the element you want. And that's really nice because back in those times, CSS was becoming the standard that it is today. And I mean, they didn't have CSS3, but the way elements are referenced in CSS still spoke very much to this hashtag notation. So it was very easy for front-end programmers to grok or understand how jQuery was going to work. Now, at first glance, this doesn't look that short, but then if we look at the next part, where we're actually going to add an event listener to this, we can then take our native element and call add event listener on it, and then specify a click listener, and then apply a click handler function, which is fine. It's pretty verbose, and especially at the time, back in the early jQuery days, this was not standard across browsers. So you'd have to create a polyfill to detect whether whether the feature is available in the Microsoft browser you're using, or in the Netscape, or not Netscape, but Firefox browser you're using at that time. It was a giant pain. So in jQuery land, you could just you could take your element and call a .on it. In those days of jQuery, it was more likely going to be a .bind or a .click sugar, and then apply your click handler. And at first, this doesn't look that much shorter than the actual modern native equivalent, but when you look at this in combination at the bottom here in this combo line, you can see in one really short line that's even shorter than getting an element in the native DOM API, you can actually get an element and bind a handler to it right away. So jQuery really did, for its time, solve a whole lot of people's problems really quite nicely. And again, most of this played right into the web world at the time. I mean, XHR was a really new thing. People weren't widely using it. It wasn't until even just a couple of years ago where single page applications really became the sort of standard place where web development has gone. Again, browsers were slow. They had less features. Dealing with things like video was complicated, and it usually meant you had to bring in Flash because there was no HTML5 video. There were no Canvas APIs or all of these other fancy things that we've seen come about in the last decade. Well, they didn't exist then. I mean, again, and displays were more limited too. Typically, most of your websites were targeting, 800 by 600, 1024 by 768, and a few larger resolutions. And then as smartphones started to develop, all of a sudden this display sphere exploded, and people needed to target a whole bunch more displays. And it's kind of interesting because around that time, people who wanted to do quote-unquote serious programming in the browser, they were often using Flash and Java and these other plugin solutions that allowed for pretty complicated programming, but these other solutions didn't really integrate with the DOM, so you never had a sort of cohesive experience. And what ended up coming about was this sort of Web 2.0 multi-page architecture. And in the Web 2.0 system, we don't really move very far away from what happened in those early days, where we have a client, it requests something from the server, and the server delivers it back. That was still very much a feature of Web 2.0. It's just that since the concerns were a little different, there were a lot of assumptions that Web 2.0 apps tended to make. And one of those was that page reloads were really common and expected. Like in a Web 2.0 app, you have a sole source of truth, which is a database, somewhere remotely. And that's still true in single-page applications. The difference is single-page applications execute a lot more logic on their own, whereas these Web 2.0 apps, that logic would be done on the server, and then the actual resulting screens would be produced in server-side templates and then sent down to the client. Whereas nowadays, most of that's actually done on the client side, and it's only data that's being transferred in between and not the actual the HTML text. And we're even going further with things like WebSockets and HTTP2, where it's not just like we're actually getting to a purer form of data being transferred. I mean, XHR data still has HTTP headers, which do add up when you start transferring really small amounts of data back and forth. But But back to the Web 2.0 architecture, I mean, we had a lot of server-side caching to reduce database queries, because most of your client state would end up living in a database or living in a caching server somewhere, so that it could be quickly fired back out to the client and reduce the time in between multiple page reloads. And HTML templates, again, were also processed on the server side and then cached so that they could be quickly delivered. And this is also interesting about Web 2.0, because we're starting to see this come back around in modern frameworks like Angular and React, where server-side template rendering is now a thing again. And so caching these sorts of things is fortunately a solved problem that we should be able to implement solutions to in our new state-of-the-art framework. So that's really interesting how these things like fashion sort of come back around in circles. So jQuery came about in 2006, and somewhere around 2008, and again, this isn't really a formal term, this second great browser war, but around 2008 when Chrome was debuted is when I personally would consider the second great browser war to start. And I consider it to start then because V8 brought to the table a just-in-time compiler. And what this would do is it would allow JavaScript to run very, very quickly and on your client device, as opposed to very slowly. So a just-in-time compiler, it'll take programming languages that you feed it, and as it reads them in, instead of just interpreting it and running the code, it'll actually convert it to a reusable machine code that it can re-reference. So essentially, your code is being compiled to a highly optimized format all the time under the hood in a modern JavaScript environment. It's being compiled into a highly optimized machine code that gets run. And V8 sort of pioneered this in the JavaScript world. Just-in-time compilation is not unique to JavaScript. I mean, this existed far prior to JavaScript. It was just that V8 was the first mainstream JavaScript engine to support it, and then the other JavaScript engines quickly followed. I mean, Nitro incorporated it. They're the JS Core and Nitro are the engines behind Safari, and I think they're built into stock WebKits too, if I'm not mistaken. SpiderMonkey backs Firefox. Kraken backed the older forms of Opera. Modern Opera actually uses V8 now. Chakra, Microsoft developed to be a just-in-time compiler for JavaScript, and I believe it debuted in Internet Explorer 9, and it really brought them up to speed with fast JavaScript. And things did get a lot better and faster. It's really hard to appreciate how much faster they got unless you were able to witness your code running at that time. But the improvements when Firefox switched to using a just-in-time compiler, they reported improvements of 20 to 40x speed improvements to start on standard benchmarks. So that's a number that's extremely noticeable to the end user. Like you could really start doing native-like things. I mean, it's not native, but it's acceptable performance. This just-in-time compilation brought JavaScript speeds ahead of other interpreted languages like PHP, and almost into the realm of where like a byte-coded language like Java is actually performing. And in certain contexts today, we actually see JavaScript outperform Java. That's not in all contexts. That would be specifically in regular expression benchmarks, but it is catching up slowly over time. It's sort of hard to compare this paradigm shift to modern browsers because trying to run the old software on a new computer is really challenging. Some other improvements that came about at the same time too, which sort of skew things, are CSS3 evolved, and so did HTML5. And CSS3 lets you take away the whole animating things with JavaScript, and it lets CSS do that work, and whenever possible, I believe CSS will even try and pass that off to the GPU, depending on the browser you're using, which means CSS just benefits from all sorts of optimizations outside of the scope of JavaScript. And browser APIs normalized too around the 2008 mark. So we started to be able to access the DOM consistently between Microsoft products and Google products and Firefox products. And like I said, things weren't native, but programming, the possibilities of what you could program on the client side just leapt through the roof. Now, just to compare over the last 5 years to try and bring this into something that's relevant, and again, I tried to get benchmarks from back in time, but that was a little harder. A lot of the data is proprietary or locked up, but I did get a copy of Firefox 4. I ran it on a MacBook Pro, which has an i5 and a bunch of RAM, and the Firefox 4 version, which came out around 2011, it got an Octane score. So Octane's a benchmark Google runs, and it's a whole series of suites that run. And the numbers might not scale linearly, but it does at least give us the sort of bird's eye view of what we can expect And we see about a 5x improvement between Firefox 4 and Firefox 45, the 2016 version I have. I mean, we're getting 5,968 is the overall score of an Octane test in Firefox 4 on this machine, and the same machine scored 29,722. And just to bring that Firefox benchmark of today into perspective, the current Opera version, which runs V8 behind the scenes, it scored about 30,842. So, a jump of 5x is significant. I mean, modern browsers are typically within, a couple hundred to 1,000 of each other, but to see such a leap, it's huge. Now, going back even further in time, that 2008 just-in-time compilation switch at 20 to 40x means that if we could even get these Octane scores running on an older browser, we'd see some really low numbers. So it's really, really impressive just how much JavaScript performance has improved over the last 5 years, let alone the last decade. And that's really changed the landscape around a bit. So with all of this horsepower being available on the client, it's suddenly possible to write pretty complicated single-page applications. Like, you can do wonderful complicated things like longer array sorts and data mutation. So you can get chunks of data back from the server and then iterate over them and produce smaller versions that are consumable by your views without impacting the user too much. You can count on your client having dedicated but sometimes limiting processing power. And I say dedicated because in the early single-page applications, mobile wasn't as big a target as it is today. So at those times, you had a ton of processing power available, but targeting mobile means you have less processing power available and less memory. So you do have to keep in mind that your client, even in 2016, could potentially have limited processing power. But the point is, it still has processing power, and it can still do a lot of wonderful things. A lot more wonderful things than a fast desktop in 2006 could do. And that's your mobile phone. Clients can have more state in a single-page application. They actually optimistically going to produce the results of server-side calls whenever possible to make the application feel very native. Refreshing the application between views and between clicks is no longer an expected behavior. So that actually really dramatically changes how people need to think about JavaScript programming. I mean, in the early days, it was really easy to sort of rely on the fact that, hey, there's going to be a refresh and it doesn't really matter what state the browser's in because that'll be corrected the next time the user goes. And so, I mean, 80% of your problem was getting the first 80% of the experience to be right, and so it's really easy to sort of shove those later hard bits off and not have your client, perform for 3 days without crashing, kind of thing. That didn't really matter in the early web. Whereas now with a single page application, your application might be loaded in a tab for a week, and you need to make sure that it can run in that tab for a week without having memory leaks. So it's very different operating on a single page application than it was in a Web 2.0 style application. And one of the other benefits is that the single page architecture, it ends up making it so that you can actually completely decouple your client and server. And this is really nice because it ends up separating your concerns quite nicely. You can remove a lot of logic from the server if you want and ship that off to the client. Now, it's important for security reasons that your server is still going to have to do intense validation and escaping and all sorts of other security-minded concerns, but it doesn't have to worry about the rendering layer or user state like it used to in the Web 2.0 days. So the sort of abstract data flow in a single page application is that the page is going to load from the server once. It could potentially even be loading from a cache. In the past, I've used HTML5 manifest to do offline caches. You can do that in like your PhoneGap Cordova sort of things. React Native offers solutions. I mean, there's a lot of different ways to make it so that you have a web page that at least can load the basic shell of an application and then not have to have data from the server right away. So there's some cool opportunities there in single page applications. Writing to the server in a single page application, that always happens in the background. So you're no longer ever doing these clicking a submit and then watching your whole page reload. That concept is out the window in single page apps. And then likewise, when that data comes back from the server, you're only going to update portions of your page, and those portions should happen transparently to the user. I mean, ideally they should happen very natively. So you might submit a form and then see it rendered even though the server request to save that form hasn't completed in the background. And better yet, a modern single-page application will actually save that request so that if the browser closes or something, when it actually resumes, it could then pick up where it left off and continue saving that if the request didn't finish. So there's just wonderful data flows you can do with these single-page applications, especially when you have a little bit of state on them and persistent state, which started coming out in the HTML5 APIs. Before things like local storage, persistent state had to be done through cookies. It was more vulnerable to cross-site scripting and cross-site request forgery. Not that modern single-page applications are immune to that, they just are a little bit more tailored around the idea that that's going to be a problem. So before modern frameworks and libraries like React and Angular and Ember and so on came out, the territory of the single-page application, so this is going back to like 2009-ish, 2010, it was a bit of a Wild West situation. I mean, due to the nature of the way JavaScript programming sort of evolved, there were, through no fault of library developers per se, there were a lot of bad practices as examples. The JavaScript language itself was deeply misunderstood by many people, especially people coming from Java backgrounds. So there were a lot of counterintuitive examples out there. And as a result, it was really easy to make mistakes in your development process and in your architecture process. Organizing code in ECMAScript 3 and even ECMAScript 5 is pretty challenging. Like, there aren't the concept of native modules in JavaScript at this time. And deploying code is a bit of an orthogonal concern to this, but it was also a problem at the time. And it's gotten easy, and this doesn't really speak to JavaScript, but it's gotten easier to deploy things to services like Heroku, or back your instances with things like Firebase. So it's become a lot easier to work with these technologies without having to set up your own sort of stack in the background and deal with all that server-side stuff. So there were a lot of challenges to making these single-page applications, and they gradually started overcoming these, or we gradually started overcoming these, I should say. One of the common backbones to all single-page applications is that XHR, or transparent server-side requests, I guess XHR-like things now that there's a fetch API and we've dealt with technologies like JSONP and whatnot. XHR and server requests are a common theme amongst all single-page applications. And this is, again, just the transparent means of being able to fetch data from a server and do some sort of manipulation on it to make it suitable for your view and present it to the user. And it's one of the most essential technologies we have. And it's kind of interesting because it was discovered almost as an accident in the early 2000s. A programmer was just hacking through the Microsoft Docs and noticed that they could do these server-side calls. They wrote a little chat application, and lo and behold, XHR became mainstream, and it was dubbed Ajax in a lot of concern. So in the jQuery library, you'll notice Ajax calls when people are referring to HTTP requests. And again, it's the backbone. Like, every framework since then has typically bundled their own XHR wrappers of some sort in there. That's not really a React thing. Since they came about later, they tend to use the Fetch API or some other polyfill for this, just because so many people have written solutions to XHR. It's almost not worth writing them anymore, but it is the backbone. And then converting data you get back from XHR really depends on your server, but typically it consists of a few list iterations and some object mapping to just reduce the amount of object properties that you put on your view, or whatever other transforms you need to do. So around this time, there was a lot of different attempts to actually scale jQuery. And what's really nice is jQuery has a good API. So it provided, a simple and rich plugin interface. You could write new jQuery modules, distribute them to your friends. There's an entire UI interface system built on top of jQuery. And jQuery calls can be encapsulated in functions pretty easily. And because jQuery is all about chaining and you always get this jQuery object back, it's really easy to compose all sorts of rich kind of tools with jQuery. But when you get into the single page style and you start maintaining state in your application and you start trying to make your view refreshes faster, jQuery scaling breaks down a little bit. And one of the reasons for this is that jQuery makes touching the DOM really easy. And that was a really good thing in 2006 when we were using it for CSS, but as much as browsers have advanced, touching the DOM is a bit of an expensive call. I've heard it likened to crossing a toll bridge where every time you go and do a DOM access, you end up paying a toll. And jQuery is all about DOM access, and avoiding DOM calls with jQuery can be challenging. I mean, it's doable, but it's challenging. And then in and of itself, jQuery doesn't actually provide a templating system. I mean, it's mostly for DOM traversal, and it's a utility driver. And again, trying to scale with jQuery in 2009-10, it became less urgent because browser APIs were largely normalized, and smoothing out the differences, it was still a concern, but it was much less of a concern, especially if you didn't need to target older Internet Explorers. But one way or another, I mean, you could scale with jQuery to a point, but it required a lot of discipline, and you'd still always left with the challenge of avoiding DOM manipulations. Again, not undoable in jQuery, but it just doesn't really lend itself well to that. So some of the earlier solutions in the early sort of single-page application framework sphere, they worked around scaling around jQuery, and they used libraries to do this. So one of the first libraries to sort of take advantage of this was Backbone. And like I sort of mentioned, jQuery was a utility library, and it still is a utility library with a great API. And Backbone attempted to sort of tie that into, and I mean, jQuery wasn't a hard dependency of Backbone, but it did, and still is, I believe, an optional dependency which can help with certain aspects of things. So Backbone would provide, data modeling and some state management and event handling outside of the scope of DOM events. And this was actually really nice. But scaling the state in Backbone became a little bit tricky, as you really had to be cognizant of how your events were going to propagate, because if you weren't careful and you didn't have discipline with Backbone, you could get into situations where you're updating in repeat loops and doing some horrible things and having weird cascades happen in your code just because you hadn't been disciplined enough when you wrote it. And then around that time, Google, before Angular 1, Google, and even during the Angular 1 times to this day, Google had their own library of tools that they were promoting, the Closure library, and they provided a whole bunch of wonderful widgets for page applications. And around this time, Angular 1.x came out, and it also baked jQuery into it, only in the sense that the Angular 1 guys used a really light version of jQuery, and you could plug in a heavy-duty version if you wanted, but it wasn't mandatory. And so that's kind of how Angular 1 adopted a lot of jQuery devs, was just by bringing them into the fold through just working with jQuery and keeping that most excellent API for accessing the DOM. But the more people started playing with Angular 1, the less they really needed to manipulate the DOM too much. They could get a lot of that done in templating, in Angular's rich templating library. And then, Angular solved a lot of problems, and then as it evolved, more and more libraries started just popping out, even in around the same time. And this isn't in any particular order, they're just alphabetical here, but you've got your Angular, your Aurelia, Meteor, Ember, and React. And React is more or less the second scope of this talk, because we're looking at migrating from this 2.0 style we've been describing to a modern React style in a single page application. And React's less of a framework and more of just a view library. But I've included it in here because the broader React community, as much as React itself isn't opinionated, the broader React community is somewhat opinionated towards the idea of Flex architecture, which isn't a framework per se, more of like a collection of patterns, but it's enough that I'm just lumping it in as a framework. And it also weighs in at I think 130 kilobytes compared to, say, jQuery's 88. So it is a fair bit of code to be pulling into a page, but that's still not very much by modern standards. So React, again, view library. It is opinionated in how you make your views, though, and we'll get into that in a little bit. But its main goal is that it simplifies writing to a page, and it simplifies the organization and the composing of parts of a page. And it's also designed under the hood for speed. It provides a template syntax, and it's mostly pure functional. So you can just, if you write your React in a very functional sort of way, all you have to do is input some properties and you get some HTML back. And we'll look at this term props in the context of React and what it means as we move along here. So trying to compare React to jQuery is a bit apples to oranges. And I know the title of this is jQuery Soup, and jQuery soup isn't so much a product of jQuery itself, it's more of a product of attempting to do things in single-page applications using bad practices from the mid to late 2000s. And unfortunately, jQuery gets a lot of bad rap for that. But really, when it comes down to actually trying to compare React and jQuery, again, apples to oranges, they solve very different problems. jQuery solves the problem of navigating and manipulating the DOM, and jQuery provides other helpful functionality like Ajax, animation utilities, and just general purpose utility functions. So jQuery was a really wonderful toolkit in the early web because you could just get one library and do most of the things you needed to do. And now we've started to look at how it's hard to scale that in a single page application, and we'll look at how React solves a different problem. React solves the problem of providing a system for composing application views. That's really different than navigating and manipulating the DOM. Like when you work in React, you're not really thinking about navigating and manipulating the DOM. You're just writing views that end up taking in properties and doing stuff. It's actually it's a very different paradigm than trying to actually find something, make a change on it, and then insert change data. Like it's instead of in that sort of imperative flow in React, you just produce a view that is a function of your state. It's really, really quite nice and easy to reason about. So bare bones React, and we're going to get into some examples which aren't really, these examples are tailored around to give you an idea of how to dive into React. They're not going to expose you to writing a scalable React application. And the reason for that is just because wrapping your head around React at first can be a little bit challenging, especially if you come from a jQuery background. So I want to just look at React from that sort of a perspective. And so what this is we have on the top, we have this React DOM.render function, and then all of a sudden there's HTML in there and some squiggly braces with a title in the middle, and then there's this document.getElementById element thing, and it's just, that doesn't really look like JavaScript to me. And it's because it's not. It's actually JSX. And what that is it's a hybrid of JavaScript and an XML format. So XML, for people who know, is essentially a very specific type of HTML, I guess is a way of looking at it. That's a bit of a colloquial way of explaining it, so please don't take that as a sort of rigorous definition, but it's basically a type of HTML that's very specific and follows very specific rules. Now, in the case of JSX, this XML construct, they actually transpile, so they get compiled through something like Babel or the TypeScript compiler to pure JavaScript. So on the bottom here, after transpiles 2, we see what the JavaScript for this looks like. And it's, React DOM.render, React.createElement, h1, we're passing a null, we pass in a title, and then we pass in this document reference to an element. And so in both these cases, element would be some string that's been defined elsewhere that's an ID of an HTML property. It's just been excluded for brevity here. And then you can see that title also would be a JavaScript variable that's defined outside of the scope of this that actually is put in. So that would be a string too. And what this does is it just spits out a header with that string in it. So there's really nothing to it. Now, the jQuery analog for this would be something like, grabbing your element, and I've used an ES6 template string here. So if you're not familiar with this syntax, this $, in here is not a jQuery call. It's just letting JavaScript know that we're going to put in whatever the variable element is. So in this case, if you have a variable defined element, it's going to look for it using the hashtag notation. So as an ID, it'll empty out that div, and then it's going to append a new div to it, which is the h1 header. And again, it's got a text and title. Another way of doing this in jQuery, because jQuery is very expressive, you could just grab the HTML and obliterate it and put it in inline. So in a lot of ways, at first glance, it looks like jQuery is a lot lighter, and in many ways it actually is. But when you start repeating these functions, React's advantages start to show through a little bit. Behind the scenes, React actually keeps track of what is going on with the document object model. So earlier we talked about how any talking to the document object model is expensive. Well, React makes it a lot harder for you to actually talk to the document object model. I mean, it's still possible. It still happens. We saw the document.getElementById here, but it's much rarer in React. You usually only do that in really specific cases. And the reason for this is that behind the scenes, React can then diff your changes and then choose not to update if it doesn't need to. I'm going to flip over to some code here, and we'll take a look at what that actually looks like. Okay, so we've got a really simple sort of heading.jsx file here. It has not much to it other than something very similar to the heading function we looked at. It takes a heading, it takes an element string and a title string, and then it calls the React DOM.render function. The index.html doesn't do anything other than set up a jQuery route and a React route, which is just where each respective framework will draw. And then here is a headings.jx, which performs the jQuery operation. Now, oops, don't want to slide over there. If I just shrink this window for a second and bring up this window in full screen, you can actually see here jQuery and React on one side. So they're both drawing out strings that say jQuery and React. But if we inspect this, this is where we're going to see the actual magic. I hope this will actually show up on your end there. What we have here is, we notice in this React route, you notice how there's no flashing? I didn't actually mention this in the little code walk there, but if we look at where these guys load, they both load into, one loads like React app here, and it just calls the heading with React root and the React title, but then it recalls that heading function at an interval of 2,000 milliseconds. And the jQuery one's doing the same thing. And what we actually see here in our browser window, and I'll blow that up again, is that every 2 seconds, the jQuery one is actually going to refresh the DOM, and that's what that flashing there is. It's hitting the DOM and redrawing it. And we notice that the React copy is not, and that's because React keeps internal knowledge of where the DOM is at, and it only updates it when it needs to. And that makes things a lot snappier. And that's just one of many ways that React actually operates under the hood, or optimizes under the hood, to keep your applications running really quickly. Now, it would be possible to do that in jQuery. Like, you could keep track of all of your elements and do the diffing yourself. And I mean, there's no reason the React team couldn't do that, but just because in interest of keeping their library of trimmer size, they've probably written really custom handlers that do these things in very specific ways that are tuned towards React, instead of jQuery, which provides general purpose tools for accessing the DOM. So we've looked at just rendering stuff with React, but that's not really how React gets used. Typically, React gets used by dividing your application into components. And the idea of components are essentially that they're HTML containers. They have limited, if any, logic. In some cases, in stateful components, you will see little bits of logic because they know about the app. But more often than not, if you want to make something reusable, it will be logic-free. Components map to atomic design principles. So if you're familiar with that sort of train of thought, this is essentially, you have atoms, which are like HTML elements, and then you make molecules, which might be a form tag, an input for text and a label for it. And then you might merge that into like a larger form that's sort of like an organism, and you build things up into little bits of your page that way. And it becomes a really nice pattern for reuse. It's a little bit beyond the scope of this webinar, but I would urge you to look into atomic design principles in your free time. There's links through the React documentation for that. And again, components can be stateful or stateless. And typically what we're finding in React projects is that the stateless components are the most reusable and advantageous to have. And these components are the building blocks of composition. So when you're building these components, they end up being things that you can end up using in this JSX syntax, just like their HTML nodes, except they transpile down to pure JavaScript. So React components, they can be expressed as pure JavaScript. But more often than not, we'll use JSX and run through a transpiler. And then they come in 3 different flavors, which can all roughly do the same things. They can be pure functions, which is a great way of ensuring that they stay simple. They can be object literals, and this is really handy when you have a little bit of state to manage in your components. And they can also be ES 2015 classes, although I think in the React community we're seeing less of a preference for ES 2015 classes and more of a preference for object literals or pure functions whenever possible. So this is a really simple React component. It's a pure JavaScript function. It takes this is a little bit of a tricky syntax if you're not used to ES 2015 or ES6. Hello message equals, and we got the squigglies in here, and there's name in there, and that's just a destructuring. So really what this is doing is it's taking a property, and in the React world this will typically be called props, and it's taking the name property off of that props and making it available for use lower down here in the actual XML portion, where these two squiggly brackets, they're not destructuring in this case, they're actually escaping the JSX and allowing you to put JavaScript in the middle, so to speak. So this will actually let you call this function, and it'll give you back a piece of JSX code that renders a div that says hello, your name. Additionally to this, the React community provides methods for typing these things. So you can specify optionally, and for the rest of the examples, I won't be using the prop types and default props just to keep the examples short, but you can specify what type your property is going to be and what its default is going to be. So if it's not provided when you call this function or when you include this in a composite component, it will actually fill in the blanks for you. So React has a lot of features for scaling. Now, if we wanted to render this function out, so again, remember, this is just a JavaScript function. It's called hello message, and it takes one parameter, which is a props object. And in this case, that props has a name on it. And if we wanted to actually render that, we can pass it into a React DOM render function. And in React, since it's all pure JavaScript, you can do pretty much everything outside of the DOM. And that's why you have to usually bring in React and React DOM, because you could write stuff in React and have it run isomorphically, or like you could run it on your server or in a worker potentially. Whereas with the React DOM, it's specifically going to talk to your browser. So in this case, we've got our hello message, and that directly references this hello message function. So JavaScript scoping rules apply. And then we notice there's sort of an XML attribute here called name, and we pass in a name variable, and that name comes directly from here where it's Pat, and we tell it what element to put this in. And that's all there is to actually using a stateless, simple, functional component in React. You just call it like it's an HTML tag in a render function or in another component, and then you can use it. And it'll transpile to pure JavaScript. So it becomes really easy to test in this kind of a paradigm. If you want to handle events, again, that's also pretty simple. In this case, I've used a slightly different syntax for creating the component. I've called it hello message click, and instead of making it a pure function, I've used the react.create class, which lets me specify an object literal, which is always going to have a render method. And in this case, I've given it a hello method. And hello is going to get called when the onClick event fires. And you just write an onClick just like you would an old school browser event. And it's kind of interesting that this syntax has actually come back into play. I mean, in the early days, in the 90s, this is how a lot of people wrote their JavaScript. They embedded it through these direct on-click handlers. And then web pages sort of became these giant monoliths, and it became really hard to manage your handlers if they were defined that way. But now that we're moving to these sort of single-purpose files and ES6 modules, it's become acceptable again to put styles and event handlers directly on nodes, just like this. So there's been some confusion that I've seen where people are worried that it's bad practice, and it was bad practice for a time, but now that we have more modern approaches for dealing with these things, it's not nearly as bad as it used to be. So what we have here is this, we've got JSX again, the squiggly braces escape that JSX, and then they let us call the this.hello method. And behind the scenes, React intelligently applies this. So you don't actually have to worry about the context being there. But that being said, you can't use a shorthand arrow function because it won't set this. So you always have to make sure if you're going to use this object literal syntax and you want access to this, that you do use a function. And in this case, we're referencing this.props.name. So since this isn't a function, I guess the question is, where does props come from? Well, we can look back at our previous example, and we can see that props get passed in through an XML attribute there. And we'll look a little bit more in detail about that before we quickly discuss state and then wrap up. So in this case, again, we've mostly covered this, but the component's now an object literal. There's a reference to this. This has a props object, and props is an abbreviation of properties or attributes. And some of that is because they're either attributes on an object that's passed down from above, or they're attributes from a component and they're passed down from above. So above what? Well, like HTML components, just as much as your HTML document is split into a head and body, and so there's two branches of the tree, and then head might have a style branch in it, and then body might have a couple different div branches, and then each of those div branches, they might have like an anchor tag or headers, so on and so forth. It becomes really easy to think of HTML like a tree. Well, components in React, they get organized like trees very well as well. And so above typically refers to further up in that tree somewhere. And some of the nodes in these trees are going to be smart or stateful, which means that they're going to know how to talk to the rest of your system somehow. They might know how to talk to one of your stores or your services that talk to servers. And some of the nodes are stateless, like the ones that we've largely looked at now. And these stateless nodes, they just get properties passed in, and then they do exactly what you'd expect them to do. So you'll need occasionally, typically a minimum of once per project, but usually not even more than that. You'll need at least one stateful component to actually hook your views into the application somehow and pass down those props. But typically you can actually get by with a lot of stateless, quote-unquote dumb components that don't have to know too much. So let's look at actually how this passing down works really quickly here. In this case, we have a really simple text input component. It takes two different properties, name and onChange, and onChange it's expecting to be a function, even though I don't specify the prop types here for brevity, and name is a string. So it's just going to put name and onChange in. Then we might have this intermediate thing that makes a bunch of different text inputs with names like first name or last name or address, and they each have their own onChange handlers. And there's different ways you could actually pass different handlers in. We could actually have named them appropriate to each thing, or created a globbing function to do it. This is mostly a demo, so it's not super designed around for functionality. It's mostly just trying to show the way props get passed down. At the top of our component, we might have something like a get form. And again, this is pretty contrived, but it'll take the name and the address and an input button, and when you have a change, it'll actually react to it. And it'll react to it based on the onChange that's set up when you actually pass in the first onChange prop when it trickles down. So all of these properties will end up calling a console log when they end up running. And there's a bunch of other things you can actually get to inside of these things to give you scope to the element and whatnot, so you know what you're dealing with. But what's really nice is that it allows you to remove that logic and take it up into the upwards portion of your code and not have to deal with that in the nitty-gritty. And so you'd end up with a form component that looks something like this: name, address, last. And just one shortcut that's nice with React is you don't actually have to say onChange every time. You can just do this ... props, and this will actually remove that onChange. So it's going to do the exact same kind of thing, except now your component doesn't have to be aware of onChange. It just needs to know forward the rest of the stuff I don't care about down. And so that's really nice. So in summary, it can be used like jQuery, but that's not really what it's for. It's a component composition tool. Components are particles of pages and applications. React works really well when it's transpiled. It's a little harder to write if you want to stick to pure native JavaScript. It scales very nicely, and it's a solution to the view problem. Now, larger application architecture is a bit outside of scope, so I'm just going to touch on it as we wrap up here. It is very important, because the problem that led to jQuery soup wasn't jQuery itself, it was lack of architecture. And that sort of came about because jQuery is a utility library, and it's not opinionated about anything, which is not strictly a bad thing. It's just the nature of a utility library. Conversely, React encourages a very specific type of view architecture, but in code terms, it's not opinionated about system architecture. So React just wants you to use components, but it doesn't really have too much opinion on what you do outside of those components. However, the React community tends to prefer Flux-like system architectures. So Flux in one slide, basically you have the concept of these actions. They trigger a dispatcher, which triggers a store, which updates your React view. And it's a one-way data flow. It's pretty easy to reason about. It's an alternative or parallel to MVC or MVVC or any of those patterns. It's unidirectional, and it separates concerns really neatly, and there's a bunch of different flavors. One of the flavors we like at Rangle is called Redux, and we've got lots of talks on our web pages about Redux if you wanted to look into it in more detail, but it's a variant of Flux, and it's almost like a client-side database. It treats state as a result of a sequence of actions, It can bind directly into React and other frameworks, including Angular, but it does make your application state easier to debug and easier to scale. And both of these things working together, whether you're using React or Redux, they are both designed to encourage you to think about things up front before you actually commit to writing. So you end up doing static interface programming to begin with, which helps you identify all of your possible states. And then once you know your states, you can define their shape. And then you just end up actually typing out applications that are really well thought out at the end, instead of writing this ad hoc sort of little bit of state here in this one component. jQuery kind of encourages that because it's really easy to declare variables and whatnot on your view, whereas in React it sort of forces you to force those things up. And a library like Redux, it lets you slice your state, so it's actually easy to reason about small chunks even though you have one sort of centralized database, so to speak. Thank you all for listening. I had a lot of fun preparing this, and the slides will be available after, so everybody have a good day. Thanks a lot.